Alright, so the following question comes from page 42, number 59 from the textbook. And given this information, it was asking what was the initial distance. So the question gave mass, final momentum, and then the time interval. Before you can actually start to the problem, it's important to notice that mass was in grams, so you have to first convert kilograms, and then final momentum was given, and we had to assume that initial momentum was zero. Also, for the time interval or delta t, even though final minus initial would give you a negative time, but the delta t represents the time it took for the action to occur. So I assumed that it was zero point 0.4 seconds instead of negative 0.4 seconds. So to find initial distance, you first had to find initial velocity. I did this by using delta p equals mass times velocity, and then I solved for velocity using pf minus pi over m, which was final momentum minus initial momentum over mass, and I got this right here. I just simply plugged in, solved. It's important to notice that once you subtract and divide by the mass, your unit is in meters per second, which corresponds to average velocity. Next, you have to find the distance, which I used using the updated distance formula, which then gave me um, zero, which then gave me the negative 11.1764 in the z direction. Lastly, just for the laughs, I found the unit vector of the average velocity, which was solved by using this equation. Because because velocity was only affected in the z direction, regardless of what happens in the xy direction, it should come to a 1-to-1 ratio. If both x and y, if there was velocity in both x and y direction, this would not be the case as in here. But if you do calculate the magnitude of the velocity average, which is simply this, which is simply the z direction squared over the square root in the scenario, you would have um, the velocity in the z direction over the magnitude, which is right there, which would give you a sum of 1.